Hello, my name is Professor David Brayden from University College Dublin, and I'm going to tell you a little bit about the TRANS-INT Project as it pertains to work being done in this university. So TRANS-INT is a major European project under the FP7 programme, and what we're doing is we're trying to deliver some candidate oral peptide molecules. So we've 17 partners, including major pharmaceutical companies, SMEs, and then some academic groups from all across Europe. And the plan is that we take peptides provided by Sanofi Aventis and we try and deliver them in a range of nanoparticles in vitro and then into preclinical animal models before taking selected candidates right through to the next phase. So the rationale behind TRANS-INT is that we don't really know how to do oral peptides. So we have many injectable peptides such as insulin and GLP-1 and calcitonin, but we don't have ways of delivering them orally. And the reason is that they are broken down in the intestine by pancreatic enzymes, so they're very unstable and get metabolized. And also they have very poor permeability and they don't cross the intestinal epithelium very well. So this is why we don't yet have an oral insulin. So if we just proceeded with current technologies, we might get 4 or 5 or 6% oral bioavailability, but this wouldn't be commercially acceptable. So the rationale of creating something like an oral insulin is that it's very good for patients to go on insulin earlier in their therapy, and also we're actually getting insulin going to the right organ, the target organ being the liver. But we need to up the percentage of insulin that actually arrives into the blood intact. So the rationale behind TRANS-INT is that we're using nanoparticle technology to encapsulate these peptides and to try and shuttle them across the epithelium, perhaps with the aid of permeation enhancers that are established excipients and are regarded as safe. So in the programme here at UCD, what we're good at is bioassays. So we'll be supplying one of our own nanoparticles as well as analysing other nanoparticles from other groups in Europe, and we'll be testing them in rat models of diabetes, and we'll be trying to rank order as to which of them is the best for delivering decent amounts of insulin into the blood of these rats. Within TRANS-INT there's a large programme in characterising the various nanoparticles from the different groups across Europe. There's also a range of assessments using in vitro models like KCO2 and also human intestinal epithelium in isolated fashion. And then there's an extensive programme which the major companies will be working on in later work packages on just 1 or 2 of the lead candidates with 1 or 2 of the lead peptides that will be used in the programme. So I suppose what the academics provide in the programme is access to different types of particle systems, which they've been working on in their labs. There's also some intellectual property built up around these particles. And what the large companies, including Sanofi, provide is their expertise in diabetes research and also access to good quantities of their peptides, which are made in their own factories. They also have great assay expertise and really understand these molecules probably better than any of the academics. So it's really this interaction that we're trying to exploit in this programme. We've got an extensive programme of 9 work packages in which we have a phased passage of molecules and particles into a funneled system by which we start out with many prototypes, maybe up to 30 or 40, and by the end of the process we'll just have 1 or 2 peptide loaded nanoparticles that we'll be taking for extensive preclinical efficacy and safety studies. We've also got an extensive education and outreach site, so we attend a lot of conferences. We present TRANS-INT at various nanomedicine conferences across Europe. We interact with other European network programs on oral peptides and also on oral drug delivery. And we also have an extensive stakeholder network where we put out brochures for the general public, and we also communicate very well through our TRANS-INT website, which is on the computer screen behind me. So in the UCD presentation you'll be meeting some of the people from my laboratory, and you'll be seeing some of the techniques that we have in the laboratories at UCD, and the take-home message is that we're providing assays and skills that hopefully are going to be very useful to this multi-million euro TRANS-INT project under the FP7 programme. This is the Ussing Chambers system in our lab that we've been using for over 10 years. It's been demonstrated here by PhD student Fiona McCartney, who is affiliated to the TRANS-INT project. We're looking across up to 8
Hussing chamber systems across the bench here. And as you can see, they're made up of complicated electrics, some computerization, and also Hussing chambers where we mount tissue from rat and humans in these chambers. Fiona's just adding some solutions to the different chambers, so that will represent the blood side of the tissue. She's looking for electrical changes, and she's also looking from fluxes from one side to the other. In this example, we're just seeing some fluorescence on each side of the chamber, representing the basolateral and apical side of the tissue. Here she is demonstrating how she analyzes tissue epithelia to calculate trans-epithelial resistance, which is a marker of tight junction opening and closing. In this screen you can just make out trans-epithelial resistance measurements. So this is done manually and also by computer, so that we average tight junction openings over a whole epithelial piece of tissue. We can then match that to paracellular fluxes of radiolabeled mannitol to see if tight junctions are opening or not. This is Svenja Sladek, who is a PhD student arrived from Germany. She's demonstrating here some of her work in trying to generate polyelectrolyte complexes, which are nanoparticles composed of positively charged polymers as well as negatively charged polymers. And the idea here is that we're able to entrap a peptide, depending on charge, between these two polymers, and that it forms a proper nano complex in the 200 nanometer range. So as you can see, it's quite a simple process involving a lot of stirring and involving simple solution addition under mixed conditions to form nanocomplexes. And this can be done really in any laboratory. The skill really is in the characterization of the materials and in working out what rate of polymer to add to the other. In this second example, Svenja is learning tissue culture, and she's demonstrating here the MTT assay. This is a cytotoxic assay used to tell whether polymers and nanoparticles are killing cells. So it's an important assay. It may not be the best one for nanoparticles, but it's a good starting point to see whether we're in the ballpark of whether these nanoparticles are going to prove to be safe when we take them into further trials. So she's doing some spectroscopy here where she's reading the MTT assay. So this would be fairly standard and is done in a larger scale in the Veneto Nanotech group in the project.
Hello, hi. My name is Sourav, and I have just started working on work package 4 of TRANS-INT Project from the 1st of March this year. I originally come from Netherlands, and I have done my master's, PhD and postdoc over there. And then I got selected for this TRANS-INT project, which I find extremely honorable post to be working on. In my project, in work package 4, we are going to select some specific nanoparticles which we think are the best to serve our purpose, and we will be doing experiments mostly in vivo with installations and oral gavage to see how helpful they can be in releasing insulin and other peptides for the purpose of drug delivery and to give it some therapeutic benefits at all. So that is my project. I've just started for 2 years. This is my first time in Dublin. So altogether it's a completely different out of the world experience, and I'm looking forward for a wonderful journey ahead. Thank you.